Hi class, so we want to start in chapter 2, which is picturing variation with graphs. So some chapter 2 topics that we're going to look at are visualizing variation in numerical and categorical data, and also summarizing important features in numerical and categorical distributions, right? And just to review, remember that numerical data is also called quantitative data, right? These are using numbers, right? Where categorical data is what we call qualitative data, and this is data that splits things into categories, right? But they can also be numbers, right? But typically it's some type of word, right? But remember we looked at, for example, last time that zip codes are numbers, but they're actually categorical data because the number is describing some category that someone is in, right? So if you live in a particular zip code, you're in that category. So section 2.1 is visualizing variation in numerical data, and some things we'll look at is exploring a distribution of numerical data, and also dot plots, frequency and relative frequency histograms, and Stemplots. So one thing you want to recall from previous is that any collection of data will have variation, right? So we're always going to have variation within our data. So and we talked about how variation is a very important part of statistics. So what we're starting to look at is what are some methods, what are some ways that we can look at the distribution or look at the variation, right? And we use a distribution as a tool for organizing this variation, right? So three main components of a numerical distribution are the following, right? So number one is shape, right? What does it look like visually? Number two, the center, or we often refer to this as the typical value. And then number three, variability. So how much horizontal spread do we have, right? Or our data's not alike, or are they alike? So here's an example of a distribution that we can look at. So this is data from NCAA, which showing the number of goals scored by first-year female soccer players in Division III. This is during the 2012 season. So here's our raw data listed, and you can note, so it appears to be from smallest to largest, but it's still hard to really get an understanding for what's going on, right? Trying to see patterns in this raw data. But distributions do record all observed data values. So here's a frequency table, right? So to have a frequency table, you list each value and then you list the frequency that it shows up, right? So remember, frequency from last time is the number of times that something repeats, right? So for example, if we look at the value 16 and it has a frequency of 4, that means that 16 showed up in our data 4 times, right? Or if we look at 35 goals, that only showed up 1 time in the data, right? So keep in mind that a frequency table lists all data values with their counts, right? And also, it can still be difficult to see patterns with a frequency table. So when examining distributions, the book recommends 2 steps, right? So number one is to visualize the data. So to visualize the data, we're going to use a graph that effectively summarizes the data, and then also we can use a picture to display the data, will help us see patterns, and the graphs that we're going to use for numerical data are going to be dot plots, histograms, and Stemplots, right? So that will be the focus of this lecture, is looking at those 3 graphs. Then the second step when you examine a distribution is being able to summarize the data, right? So you want to look at shape, right? You want to notice, is there symmetry? You also want to look at center. Is there a most common value, right? And then also spread. You want to think about, are any data values far from the rest of the data? So when we're visualizing data, right, keep in mind that the goal is to use our picture to display the data to help us see patterns, and that different visual representations capture different aspects of the data, right? So as we look through the graphs, we'll talk about some pros and cons of each type of graph, and so you can understand that different aspects will be shown and some will be lost depending on what visual aid that you use. And then the picture must also record the data values and also indicate the frequency or the count of the data values. So the first graph that we're going to look at is a dot plot. So a dot plot is a graph that records the data values on a number line with a dot above the number line for each data value observed, right? So for every data value that we have, there's going to be one dot, right? So every single value from our raw data is listed here with a dot, right? So remember, here's our frequency table, and here is the dot plot, right? So notice we just make a dot plot, and you list the dot. So when you have more than one dot in a column, right? That means they have the same value. So like these dots, there's 1, 2, 3, 4 that have the same value, right? So if we look at our frequency table, that would come from the representation of 11, right? So from just the graph, it would be hard to know for sure. We could estimate what this value is, but since there's 4, and by looking at the frequency table, we can easily see that would be 11. Right, so here's another example of dot plots. So notice the title at the top. It says dot plot of the cost of books at the college bookstore. And then across the horizontal axis, we have the book cost. Right, so for every dot on there refers just to one textbook. Right, so every piece of data is present in our visual aid, right, our graph. So we're asked 3 questions about this graph. So the first question says, how many textbooks cost $150 or more? Right. The second question is, what percent of the textbooks cost $50 or less? And then the last question is, are there any unusually expensive or inexpensive texts? Right. So let me go to the next slide. So these are the solutions that I got. Right. So I got that 4 textbooks cost $150 or more. Right? So to be able to do that, we look at 150 and go up, and we count how many would be to the right of 150. Right? So there's 1, 2, 3, 4 dots, right, that are 150 or more. And then next we would look at let's see, the second question, right, was what percent of the textbooks cost $50 or less, right? So to figure out the percentage of textbooks that cost $50 or less, we would do something similar, right? We would look at 50, and we count how many dots are to the left of 50, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 would be my numerator, right, to calculate a percent. If I want to find the percentage of textbooks costing 50 or less, right, we look at how many cost 50 or less, which are 8, and then we divide by how many dots there are, right? So if we count all the dots, right, including the ones that are less than 50, you should get 23, right? So if we take 8 divided by 23 and then multiply by 100% to put it in percent form, you should get 34.8%, right? So 34.8% of the textbooks cost $50 or less. So then the last question, if you remember, asked about are there any unusually expensive or inexpensive texts, right? So by looking at this this dot plot, right, notice that this value 300 seems way off, right? It's like far apart from the group, right? That's really the only big gap here is between this dot and this dot close to 300, right? So the text that costs close to $300 seems to be unusually expensive. So some advantages of a dot plot is it shows individual data values, right? Every single data value is present in the graph. Nothing is lost, right? And it also does help us investigate the shape of the distribution. But some disadvantages is that dot plots are not very common, and they can, in my opinion, they take a lot more time to graph, right? And then another disadvantage is they're not great if you have too many individuals, right? If you have lots and lots of data, trying to draw a dot for all of those pieces can be very time consuming, and may not display your data very well. Right, so an alternative or another way to visualize data is through a histogram. So a histogram is a little different. A histogram is a special type of bar chart where the bars are right next to each other, and the bars are showing the frequency, the count still, right? But the width of the bar, the bend width, talks about what how big the category is for that bar, right? What's the class width? What's the range of data values that you're counting in this group, right? So we don't do this for every number typically. Typically we have a range of data values, right? We're going to look at this more. So here I have listed with a histogram that you group data in intervals called bins, right? So it's the width of the interval equals the bin width. And then you're going to count how many data values fall into each bin, right? So we set up these bins, these categories, and we count how many fit into that. And then each rectangle will have the following properties, right? So the consecutive bins are going to touch, right? They're going to touch each other, the bars. The first value in each bin is going to be recorded on the horizontal axis, and then the height of each rectangle corresponds to the count. Right? So here's an example of a histogram, right? So here we still have our frequency table listed here, but we need to create a histogram from this data. So it looks to be that the bins that someone had set was from 9 to 11, and then 12 to 14, and so forth, right? So remember the value listed here at the bottom, that's the start of each bin, right? So we would go 9 to 11, and then 12 to 14, and then 15 to 17, and so forth. So the numbers between 9 and 11, notice if we follow up to the frequency, that's at number 5, right? Which is consistent with our frequency table, right? We have 9 and 11, and there's 5 total, right? 1 plus 4, right? So the vertical axis will show the frequency, right? But we can also have this show relative frequency, where relative frequency is the percentage of data in that group, right? So you can also change it to be relative frequency, right? And something that you want to keep in mind, so this is another histogram using the same data, but the difference is the bend widths were changed, right? By changing the bend widths, that can have an impact on the overall shape, right? So that's something to keep in mind, that you don't want to take a histogram too literally, because we can it can change a little bit depending on what you choose to be the bend widths, right? So we do this to get an overall sense of our data, not to draw super hard conclusions from. So some notes about bend width is that if you have a width that's too narrow, it's going to show too much detail. But if it's too wide, then we're going to lose detail. It's going to hide detail, right? And also a note is that most technology that we look at is going to choose the bend widths for us automatically, right? So I'm going to show you how to do a histogram on the TI-83 or 84, and then also how to do it with an R. So some advantages of histogram is that it's great for large data sets. It also helps focus on the general shape of the data, and it's easy to spot outliers, right? So histograms are probably the most common of the three, and probably the most preferred, right? But some disadvantages that we do have with histograms, right, they're not perfect, is that we do lose individual data values, right? So in the dot plot, we have all the data values present, where in the histogram, we lose that sense, that touch with each data point. And then also the distribution shape can be affected by the change in the bend width, like we talked about. So that can be a negative part also. Right. So this slide I'll actually pull up in a little bit. and use that as a guide to help show you how to make a histogram inside your graphing calculator, right? So the next way to visualize data I want to look at are stem plots. So we call them stem plots, or sometimes they're called stem and leaf plots, right? So they're similar to dot plots in the sense that all individual data values are present, and this also can be useful when we don't have technology available with us, or if the data sets are really large, right? So here's an example of a stem plot. So it says a collection of college students who said that they drink alcohol were asked how many alcoholic drinks they had consumed in the last 7 days. Their answer were the following, right? So here is an example of a stem and leaf plot for this data set, right? So with the stem and leaf plot, you want to think of the stem. These are the tens place value, right? Where the leaves list the ones place value, right? So like for example, if we combine 0 with 2, right, that makes the number 2. So we have 1, 2, 3, 3 2s, so there should be 3 2s present with the 0, right, matched up, right? And I'm going to do an example of making a histogram and a stem plot by hand, and in the coming time in this video, so that will probably help you get a better understanding also, right? Whoops. Alright, so that's the end of that section. So now I'm section 2.2, which is looking at shape, center, and spread, and also outliers in our data, right? So looking at summarizing important features of our distribution. So shape, so we have 3 basic characteristics of shape. Some things we want to focus on: is the distribution symmetric or is it skewed, right? Also, how many mounds appear, right? And then also, do we have like some really large or really small values present, right? So here's an example of a symmetric distribution, right? And something you want to keep in mind when we're working with data is that we're never going to have a sample that's purely symmetric, right? Or very rarely. So we're looking for overall shape, right? And I also have in the coming slides some examples to show you how this looks in the real world, right? We're not going to get this perfect shape, but this is just to give you an overall sense. So a symmetric distribution looks like this, right? The left and right look roughly the same if we were to draw a line down the center, right? And here is an example of skewed, right? So skewed happens when most of the data is on one side or on the other side, right? And we also have like this long tail, which so that the tail would be like the smaller values, right, where it's shifted away from. Right. So then, as we said, another thing we want to look at are how many mounds are present. So here's what we call a unimodal piece of data. So there's only one main mound, right? So a mound you can think of as like a hill in the data, if you will. And then if we have 2 mounds present, then we can call that a bimodal distribution, right? And then if we happen to have more than 2 main mounds, we call that multimodal, right? And when we have 2 or more mounds, typically what that is an indicator of is that we have more than one group that stands out within our data, right? So for example, if I were to measure all the heights of the Marian Tech College students, I would, 9 times out of 10, or very likely we're going to get a bimodal distribution, right? Because what's going to happen is, or what we would expect to happen is that they would have 2 different mounds, and that would be an indication of males and females, right? So we're going to have some variation within our data, but it'll, generally speaking, it'll create like these 2 mounds where, like, if this is our height chart, our height distribution, on the left maybe the male heights, and on the right maybe the female heights. Right? So some things to keep in mind with mounds is that mounds can be different heights, right? So if we have a bimodal distribution, the mounds don't have to be the same height, but they can be the same height, right? They don't have to be the same, right? They can be different. And bimodal and multimodal data may indicate the existence of different groups within the data, right? So that's what I was trying to explain with the height reference on the last slide, right? So if we have bimodal or multimodal, we might want to investigate the data further and see if there are maybe more than one different kind of group in our data. So if that's the case, it's more preferable to separate that data into two or more groups, right? So that way we can look at graphs of each group, right, and then get a better understanding for what's going on, right? So these are just some examples that might cause more than one mound to happen. So like I mentioned, we could measure men and women's heights all in one group, and we would expect a bimodal distribution. And then we could also look at like afternoon and evening sales at a restaurant. That would also be probably cause a bimodal distribution. Right. So here's some examples with shapes. So here we have listed what shape would you expect to see in a histogram of the following data sets. Right. So we have GPA of college students, SAT scores, last digit of Social Security number for random sample of students, and then income of U.S. residents. Right. So on the next slide, I indicated what we would expect to happen. So for the GPA of college students, we would expect it to be skewed to the left, meaning that a lot of our a majority of our data is going to be skewed towards the right direction, right? So let me draw a picture of this for you. All right, so as I was saying, if we had GPA college students, we would appear that would be skewed to the left, right? So we would be looking at a distribution, probably looks something like this, right? Where more of our data is to the right, and this part is called the tail, right? So looking at probably something like this, right? Maybe that's a little more apparent, right? So our data is skewed more to the right, right? And then for SAT scores, we would expect this to be symmetric and what we call unimodal, meaning that we would expect this to be more like normally distributed, right? To appear normally distributed. And then looking at last digit Social Security number for a random sample of students, we would also expect this to be more symmetric and uniform, right? Because this is going to happen at random, people being selected for the last digit Social Security number. And then income of U.S. residents, right? So if this is income, right, where here this is low, here is high, like, I don't know, $1 billion, right? We would expect a lot more U.S. residents to be on the left side of the data, right? So that's why we would say this is skewed to the right, right? Skewed to the right. All right. So then something else that's important in this section is looking at some extreme values with the shape, right? So what we're looking for, do we have any outliers? Do we have any extremely large or small values? These are values that don't fit in the pattern of the rest of the data, and also this is up to interpretation, subject to opinion, so they're not precisely defined. So when we look at extreme value, when you see extremely large or small values, you want to report the values, but you also want to realize they could be sources for error, right? Like if you have someone typing in your data, then they may have made an error, right? Maybe put in too many zeros, or maybe only put 1 instead of 15 in and actually hit enter and so forth, right? So these could be an error, but they could not be an error also, right? So you have to consider that. And then also outliers are usually interesting data values, right? So maybe this extreme case where like we looked at the goals, like someone had over 30 goals, like maybe that's just a really great player, right? So it's very interesting to look at the people who or the subjects that are outside of the typical rest of the data. Something else that we want to look at is the center. So the center is referred to as the typical data value, right? And this also could be different from person to person, right? In the coming slides, we're going to talk more specifically about different ways to measure the center or find what you could use as the typical value, but that is up for interpretation, right? So for here, I'm still looking at Division III first-year women and men soccer players in 2012, right? With this data, and a histogram was created for both. So the typical score for women that I would pick would probably be about 16, and for men probably about 13, right? So then on this slide, we want to also look at variability. So we want to look at horizontal spread in the histogram or the dot plot, right? Remember, horizontal is going left and right, right? So if all of our data values are similar, we're going to have a narrow graph, right? But if all of our data values are different, we're going to end up having a wider graph, right? Or we're going to have more variability in our data. So then just in summary of what we've looked at, so if you want to describe numerical distributions, you always want to remember that they have 3 components, right? Remember, the first component is shape. Is it symmetric, skewed left or right? How many mounds are there, right? Do we have some modes? Number 2 is the center. What's the typical value? And then thirdly, look at the variability, right? What's the horizontal spread that we see, right? All right, so here what I want to look at are some distributions, right? Oops, sorry, let me get rid of this. Right, so we just want to look at some distributions. So I deleted box plots. We're going to look at that a little later in the text. So I thought this would be helpful to see a table where we have different distributions, what its histogram is, or what a potential histogram could look like, and then what the overall distribution shape looks like, right? So I think it's important to consider both, right? So this first distribution, right, that's described, this would be a symmetric distribution, right? So symmetric, remember, meaning that, overall, if we were to draw a line down the center, it looks like it would have equal amounts on the left and right, right? It looks pretty symmetric. It's not skewed, right? The next example, the next row, this would be an example of a right skewed distribution, right? Skewed, right? So notice that a lot of our data appears to be towards the left, right? And this piece where this red arrow is, this is called the tail, right? Or this part here, this is the tail. Right? So then the next row, this would be a left skewed distribution, right? So it's the opposite of right skewed. The next one, so this has 2 mounds, right? So we would call this a bimodal distribution. And then lastly, this distribution appears where all the values are pretty close to the same, right? So we would call this a uniform distribution. Right? So these would be the most common distributions that you'll come across, right? So this handout will be on Canvas, and I would highly recommend you print this out and keep this by hand so you can remember all the distributions and their names and about what one would look like, right? All right, so let me get out of this. So the next thing that I would like to do is to I wanted to work some examples by hand, right? So let me find where I had this. Here we go. Right? So here's the example that I wanted to look at. So I'll also post this on Canvas, so you can print this out. So we're given a table where we're told the number of touchdown passes for all 31 NFL teams during the 2000 season, and we want to answer some questions about this, right, to try to understand the distribution. Right. So the first thing we're asked to do is create a histogram, and then lastly to create a stem and leaf plot, right? All right. All right. So to create a histogram, the first thing that I would consider is we need to figure out what the class width is going to be, right? So I would say the class width is equal to the maximum minus the min divided by the number of classes that you want. Right? So just a refresher, if you don't know this term already, the max is equal to the biggest value, right, in our data, and the minimum is the smallest value, right? So if we look here, I got the maximum to be 37, and the minimum I found was 6, right, from this data set, right? So here's the min, and then 37 was here, right? That's my max, right? So we want to take the max minus the min, so 37 minus 6, and then divide that by how many classes you want, right? So I'm going to do 7 classes, right? That seems like a good number, but you can change that depending on your preference, right? So let me grab a calculator. Right, so we take 37 minus 6 and then divide that by 7, and we get this value, right? So I'm getting 4.42857, so forth, right? So what we want to do in this case is you want to take what's called the ceiling of this value, and what the ceiling means, right? So these symbols denote ceiling, right? So ceiling's on the top, right, of a house. So that can help you remember that. So a ceiling is you just always round up, right? So you don't round in the sense where you round to a specific place value, always round up to the nearest integer, right? So if you have 4.0001 and you take the ceiling of it, you get 4, right? If you have 4.9912, take the ceiling of it, you would round up to 5, right? Whoops, and I meant that you would round this up to 5 also, right? Sorry about that, right? So the ceiling is you always round to 5 no matter what, right? Everything goes to 5. So if you have 79.0003, this, if you take the ceiling of this would round to 80, right? Always the next. So in this case, we would round this up to 5, right? So ceiling is always round up to the next number, right? So we want to have a class width of 5, right? So now what I need to do is create my table to use, right? Create my frequency distribution. So we can just create a table where here we have my class. I like to have a column for tally, and then a column for the frequency. Right, so classes, we would go from 6 to 10, right? 6 is my minimum value, and I want to have 5 numbers in this class, right? So if you want to have 5 numbers, you add one less to the original value, right? So if we look at the numbers between 6 and 10, this would be 6, 7, 8, 9, and 10, right? Notice there are 5. 1, 2, 3, 4, 5 numbers through 6 through 10, right? So you always subtract one, or you add one less, right, to get the widths. So next we would have 11 to 15, and then 16 to 20, and then 21 to 25, and then 26 to 30, and then right, and then 31 to 35, right? And my maximum value was 37, so I need to go one more. We would go 36 to 40, right? So these are my classes, or in the book they refer to these as the bins, right? So that means the same thing. So then what I would do is go through and just go through every number, like 37, right? Cross that out, and that falls here, right? So we put a tally mark for 1. And then you do 33. So 33 would be in here, right? So I put a 1 there, right? And then we have another 33, so you put this here, and so forth, right? So you just tally, go through by each number, and then in the frequency you're going to put the actual values, right? So like here we put 32, so there's one more here in this class, and there are no other numbers between 31 and 35, right? So I would put a 3 here for frequency, right? So we can do that with all the numbers, right? Or that could be very time consuming, especially depending on if you have a lot of data. So one thing you could do alternatively, I think I have this listed here. Right, so I did this just a little bit ago. So I entered in all my data values into this Excel file. So let me undo, so that way I can show you exactly what I did. So I just put TD at the top for touchdown, and then I typed in all the values, right? So I had 37, 33, 33, so forth. So type them all the way down, all the way to 6, right? So I just went in order of what's in the table. So now, if I highlight just the numbers, or actually, what I can do, I can also highlight the. You can also click here and do the whole column, right? So I'll highlight these values, and then if I go to the data tab, then I can click this A to Z sort. This will sort smallest to largest, right? So it'll put them in order from smallest to biggest, right, for me, right? So now it's a little easier to see if I want to look at the data. Let me zoom in here for you. If I want to look at the data in between 6 and 10, right, I just have 2 values, right? So I could just put 2 here, right? If I look at values between 11 and 15, right, we can just count, and this makes it easier to count. So I have 6 values, right? Right. And then we go 16 to 20, right? So I can highlight the ones 16 through 20, right? And also one thing to point out is, if you notice, after I select these values, if I look down at the very bottom of my Excel worksheet, it tells me the average of those selected cells, the count, so how many there are, and also the sum, right? So I don't necessarily have to count all of them. I can just look at this count here at the bottom, right? So there's 9 numbers in between 16 through 20. Right, so 9 here. If I look through 21 through 25, so there are 7, right? 7 numbers here. Then we can look at 26 through 30. So I get 3. 31 through 35, there's 3, right? And then there's 1 that's 36 through 40. Right? So in this total should be what, 30, 31, right? Because that's how many pieces of data we have. So now I can use this to create a histogram. So a histogram, we're just going to create a bar chart, right? So I'm going to make my vertical axis right, and my horizontal axis right? So then I'm only going to put marks for the beginning of each class width, right? So I'll have 6, and then we would show right, so the next beginning would be 11, right? So I'm going to skip a line in between, right? So we have 11, and then 16, and then 21, and then 26, and then 31, and then 36, right? So we need to create our bars. So along the vertical axis, the highest number we need to go up to, the most frequent, is 9, right? So I'll just go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so going up by ones. Right? So then from 6 to 11, right, we had 2. So, right, so we go up to 2. We can just make a box, right, and you can shade this in if you want, right? And then the next is 6. So we go up to 6, right, which was here, and then go over and down. Right, so then the next class had 9, so go all the way up to 9, and go over and down. And then the next class had 7, which was here, right? So we go down, right? And notice all the bars are touching, right? And then the next is 3. 1, 2, 3. And then 3 again, right? And these are highlighted in. And then our next class had 1, right? So and this was would be what, 41 listed there, right? So there's our histogram of the touchdowns, right? So now let me show you how to create the histogram inside of the graphing calculator. Right, so let me open up the graphing calculator. So to do this, you're going to click on so first we have to turn it on, right? So let me clear this. So you'll hit Stat, and then we're going to go to edit, so hit enter, and then now these are lists, right? So we can have different lists. So all of this data is going to go into into L1 for list 1. So I can type 37, my first number, hit enter, and then 33, enter, 33, enter, 32, enter. Right, so let me make sure I don't miss any. So we did 37, mark this on my page. So we have 37 done, and then we did 2 33s, 32. So then I have 29, and then 28, and then 28, and then 23, and then 22, and then 22 again, 22 again, and then we have 1, 2, 3 21s, and then 2 20s, and then 2 19s, and then 1, 2, 3, 4 18s. So 1, 2, 3, 4, and then a 16, 15, and then 1, 2, 3 14s, 2 12s, and then 9, and then 6. Right? And I know I didn't miss a data point at least, because notice here it says L1 and then 32 in parentheses, right? That means the 32 member. So that where that blank is 32. So there's 31 data entries then, right? Which is what we want. So now we hit the second button, right? Hit second, and then hit Y equals to get the stat plot, right? And then this brings me to this menu. So now I can hit enter to go into stat plot 1, and we're going to turn this on, right? So currently it's turned off, right? See how that is highlighted. So I hit enter on one or an on, and that will turn it on. And then now I'm picking the type of stat diagram I want, right? So I want a a histogram, right? That looks like this, a box, a bar graph, right? So then I hit enter on this to highlight that. And then here, XList, this is where I'm telling my calculator where my data is. So I did enter all this in L1, so we want to leave that as L1, right? So then now what I can do is go to zoom, right, which is here. Oops. Hang on. Something went wrong here. Let me quit out of that and go back. So that's on. Let me double check, make sure it's saved. Yeah, that looks good, right? So let me try this again. Hit zoom, right? And then I want to go down to option 9, which is zoom stat, right? Hit enter. And there's my histogram, right? So let me delete that off. Oops. Right? So there's my histogram displayed on my graphing calculator, right? So that's another way you can make a histogram. And typically we don't necessarily do something like this by hand anymore, but I think it's still helpful to learn how to do it by hand, so that way you know what the calculator is doing, and or you know what the computer is doing, and you can interpret what's going on, right? All right. So then, lastly, what I want to do is I want to show you how to put this into R, right? So to put this into R, what we need to do is we need to first create an Excel file, right? Which we already did, right? I already typed this data into Excel. So, and then if you go to File and then Save As, right? Then you can choose where you want to save this to. So I'm just going to save this to my desktop. The important thing here is by default your saving settings will probably be here on this Excel workbook, right? The file type. But to working with R, you always want to save the file as CSV, comma delimited, right? Just this one here, CSV. So click that, and then we want to save, right? And it's going to say, do you want to replace? And I'm going to hit no because I already did this. But just so I wanted to go through this still, so that way you knew how to make the file and save the file, right? So your computer won't pop up with this, right? Unless you already have a file named TD, right? And when I work with R, I like to have my file name something very simple and easy. You know, because you'll see in a minute we're gonna have to type that in. It just makes life a lot easier if it's not super long. All right. So now what I need to do is I'm going to open up R, right? So we can actually, I can exit out of Excel. I don't need that anymore, right? So I'm going to go into R, and first thing I like to do is make the font larger. So if you go to Edit and then GUI Preferences, now I can make this a larger font. So I'll do 14 for you, right? All right, so now inside of R, this is where we're going to type in R and tell R what we want it to do, right? So R is a command based language, right? So the first thing that you want to do is we need to tell R where is the file stored at? Where do we want to work in our computer, right? So what first thing I do is I type get wd, right? So where we're telling R where we're working, this is called the working directory. So if we do get wd and then put an open and then a close parenthesis with nothing inside, and if I hit enter, that will tell R where my computer is currently wanting to work in, right? Now, if you remember right, I saved my file on the desktop, right? So what I want to do is tell R that I want to work on the desktop. So we need to do what's called set the working directory, right? So I need to do a command set wd and then enter in the where we're working, right? And you have to put this in quotes, right? So what I would do is we can just copy this up here, right? Copy, hit paste. And then instead of documents though, I want this to be desktop, right? This is where I saved my file, right? So we change that to desktop, right? So yours should look very similar to this, right? So this is the file path to where we're saving our documents, right? So I can hit enter, and nothing here is good, right? If R doesn't pop anything up or yell at you, that's good. It means that R knows where we're working now, right? So nothing is good here. The next thing I need to do is I need to tell R what data I want to work with, right? So next is here. This is where we can name our data. So I'm not too creative. I would just name my data, right? And then you can just hit this button, right? So it's right beside the letter M on your keyboard. You hold shift and hit that, and then right beside the number 0 you hit a dash, right? So this we're saying have data be equal to the following, right? So then we would do a read.csv code. So this is telling R, hey, I have a data file. I have a file that's in CSV format, right? So if I do read.csv and then open my parenthesis, and then you'll want to put this in quotes, and you want to put the file name, right? So I named this capital TD.csv, right? And then end quotations, close my parenthesis, right? Now I hit enter, and again, nothing is good here, right? Now what you have to do is you have to what's called attach your data, right? So we have to go attach and then put the word data inside of the parentheses and hit enter, and again, nothing is good, right? So basically, all we've done so far is tell R where we're working, what file we want to use, and we want to refer to that file as data, right? So the next thing that I always like to do after attaching my data is to use the code names. So I can do names and type in data. And what this does is this will tell me my variables that I have for data, right? So if you remember right, so if I go back to our Excel file, right? So I called this touchdown TD. Right, so if you remember right, I put TD at the top, right, of our data file. So this is the name of this column, right? This is naming my data. So I'm referring to as all of this data points as touchdowns, right? So if we have, so when we talked about this in chapter 1, right? So this would be an example of data where we can list multiple variables, right, about a specific source, right? But in this case, we only have one variable. Right? Sorry, so I think I'm done with that. Let me go back into R. Right? So now, to create a histogram, you just use the code, the command histogram. So HIST, and then in parentheses, we're going to put our variable TD. Right? So we're telling R, make a histogram of the variable TD. Right? And if I hit enter, now my histogram will pop up. Right? And I can click this button here to minimize that so it's not the full screen. And now you can see that I have my histogram for touchdown, right? And you can save this or print this by right-clicking on it, and you can copy as a meta file or a bitmap. It doesn't make a difference. And then you can also save as a meta file, right? So you can copy it and paste into a Word document. You can save it as something, or you can print it out, right? So there are some options there with that, right? All right. So then also, I'll go ahead and show you how to do a stem and leaf plot, right, in R. So to do this, you use the command stem and then type in TD and hit enter. And you can see that there's a stem and leaf plot already here listed, right? So you can see that. All right. All right. So I think I'm done showing you things in R for now. So we'll practice this a few times, and your assignments won't be super, at least in my opinion, super hard. I'll post some videos doing an example, like working an assignment very, very similar to the one that you'll be doing for R. So I wouldn't stress about it, right? Again, the reason why I want to show you R is because if you're gonna do statistics on the job, you're gonna use something like R or Excel in order to do that. So I want to give you some skills to be able to be marketable in the job, right? All right, so let me go back to this example, right? So the next thing we want to do is to create a stem and leaf plot, right? So I'm going to copy this our data and bring it down here so that way it's easy for me to read. Right, so there's my data table. Right, so I already showed you how to make a stem and leaf plot in R, but I want to show you how to do it by hand so that way you have a good understanding of how to read a stem and leaf plot, right? All right, so I just want to make a note of the min and max that we looked at before. So remember, my minimum value was 6 and my maximum value was 37, right? So when I create a stem and leaf plot, we have to separate our numbers, right? So for example, let's just look at the number 37. So I split my numbers, right, 37, and this is referred to as the stem, and this is referred to as the leaf, right? So So I split the numbers, and the tens value become the stem, and the ones value become the leaf, right? So that's what we want to do for all of our data values, right? So here's stem and leaf, and my minimum value is 6, so that's going to have a stem of 0, and then my max is 3. So I want to go from 0 to 3, right, along this side. So now we're going to pick each number and write it in the appropriate 10 spot, right? So like if I look at the number 37, right, I'm going to in order to have the number 37, I'm going to write 7 here beside the 3, right? That means 37. And then we have the number 33, so I'm going to write a 3 beside the 7 because it's in the 30s, right? So we have another 33. And the trick here is to get to write your numbers like the same width, because we're going to use like the tallest bar, if you will, as kind of like a histogram, right? So you want to try to make your numbers the same width, which can be kind of hard. So that's a benefit of using technology rather than handwriting. So if it's really close, it might be better to do it with a computer, right? So the next number is 32, so I'd write a 2 here, right? Cross that out. Then we have 29, so we get a 9, and then 28, and then 28, so I put another 8, 23, 22, 22, 22, 21, so we got 1, 2, 2 21s, 3 21s, and then 2 20s, so 2 zeros, right? And then next we would have a 9 here for 19. We have 2 19s. So we got those. And then we have 1, 2, 3, 4 18s. So I need 4 8s. And then 16, 15, 14, 1, 2, 2 more, 2 12s. And then now we have a 9 and a 6, right? So now you can see, which one has the tallest bar, right? See the distribution, right? With the stem and leaf plot, right? So this one appears to be the tallest and most frequent, right? So if we look back at our frequency table, that would probably be true, right? Yeah, that would definitely be true, right? And it's not going to look the same as my histogram, because with the stem and leaf plot, you're forcing your class width, your bends, to be 10. The class width to be 10, right? So up here, our class width was 5 is what we did. So it's going to be a little different, right? All right, so that should wrap up sections 2.1 and 2.2. Feel free to contact me if you have any questions.